quite a pleasure to be here. It's incredibly exciting. This is the second time I'm here. The first time was during the pandemic when I had a chance to meet with Pat. Incredible individual, and it's been an incredible journey. A lot of the work that I've been doing started, actually during when I was a medical student. I worked with the NIH, and a lot of mentors there. They really promoted innovation, and they promoted ability. They promoted being very creative, and some of the stuff that I was working on actually had to do with longitudinal data. And the longitudinal data basically led me to think of an innovation that can actually improve not just one person or two person, but an entire system. At the time when we worked a lot on that, the technology was not quite ready. So I went back, did cardiology fellowship, and then that vision and that question just never went away. And it just kept burning, and then eventually the time was right for it. And I think that's kind of when I met Pat, and things really happened from then forward. No, that's a great question. So we consider it as the great equalizer. And the reason for that was when we first started, we did something, did optimizational strategies for many different patients. But the problem has always been is you still had to classify the patient. You had to have someone sit down, the physician, talk to the patient, and then eventually classify it. And then once you had the classification, you know what to do with them. The disease management part becomes easy. It turns out that once we bumped into neural networks, that changed everything. It changed everything because when we first started, we were working with images, and images were really hard. There was no way to, other than defining specific features, there was no way to make something recognize the image of itself. We were working with bones at the time, and making things recognize certain anatomy was very difficult. The neural network and what eventually became one of almost the Nobel Prizes of computer science really solved all that. And it was an instant recognition at the time. This was, several years back, but I recognized that if you can do images, you could do natural language, and then you can also do vital signs, you can do lab data, you could do the patient. And it was at that point in time I began this journey of being able to put a system in place where the system can see the patient, but not just that, but be informed by its own decisions, informed by how well it performs and improve over time. Yeah, 100%. We consider it as the GPS of healthcare. So essentially, a physician during a day's time can go through many different things, being distracted, working on multiple patients at the same time. What would be really incredibly great is to have the orders pre-teed for the patient, not for the patient, but for the doctor. Have the diagnosis listed in front of them, displayed all the time. The right diagnosis, the right prescriptions, the right prognosis all the time. And it turns out that we actually can do that. And so what it looks like is, imagine not having a GPS in your car and driving Chicago, it'd be very difficult to do. But if you had that GPS, you know exactly where you are. We're creating a system like an EMR, but not an EMR, to be able to drive the physician in all those different avenues.